Welcome to this exciting new chapter, an introduction to Java. If you're wondering why Java is still a big deal, let's have a look at it. Java is everywhere, quietly running behind the scenes of the world's most popular application services. From banking apps to Android phones, Java powers technology that billions of people rely on every day. And the beauty of it, you write your code once and it can run anywhere, on Windows, Linux, or Mac, thanks to the power of the Java virtual machine. But Java isn't just surviving in this modern world, it's actually thriving. Whether it's creating microservices using Spring Boot, working with big data tools like Apache Hadoop, or even AI-driven application, Java is right there at the heart of it all. And if you're thinking about your future, this is definitely a career-safe choice. Java does remain to be one of the most in-demand languages across the global markets. And when it comes to tools, Java has you covered. You've got mature frameworks like Spring, Hibernate, powerful IDEs like IntelliJ, Eclipse, NetBeans, build tools like Maven and Gradle, which make the process of development much more easier and also enjoyable. And the best part is Java is actually quite beginner friendly. Java's clean syntax and strong foundation in object-oriented programming make it an excellent choice for anyone who is interested in learning a new programming language. And as you grow, so does Java. It's built to handle everything from simple scripts to even the most sophisticated, complicated projects, running at massive scale. So if you're ready to build some real-world applications using Java, this is where we start. Let's get into it, shall we? Now that you know why Java is worth learning, let's take a step back and try to understand what Java actually is. Java is a popular and versatile language that is used to build everything from mobile apps or desktop tools to large-scale enterprise-level systems. One of the Java's core principle is write once and run anywhere. That means your code doesn't need to change. You just write it once and it can run on pretty much any operating system, be it Windows, Linux, or Mac. This is possible thanks to the concept of Java Virtual Machine. Think of it as a translator that runs your Java code on any device, making Java platform independent and truly universal. Java is also very beginner friendly. Its clean and organized structure make it easy to pick up, especially if you're just starting out with your programming journey. When it comes to its strengths, Java checks all the boxes. It's secure with built-in protection mechanisms. It's fast and efficient, optimized for better performance, and it's scalable, meaning it can grow with your project from small utilities to even complex enterprise systems. And with a rich ecosystem of libraries and frameworks which are available, Java lets you build powerful solutions without reinventing the wheel and writing your code from scratch. In short, Java is a reliable, secure and scalable language that has stood test of time since it has been around. Now that we know what Java is, let's spend some time understanding what makes Java so powerful. Platform independence. Java lives by the promise of write once and run anywhere. Thanks to its concept of JVM and bytecode execution, your applications can run on Windows, Linux, or Mac, and you don't have to change a single line of code. Robust memory management. With automatic garbage collection and strict type checking, Java takes care of the memory behind the scenes, keeping your programs smooth and error-free. Object-oriented programming. Java is built on object-oriented principles like encapsulation, inheritance, polymorphism, abstraction, making your code much more modular and reusable and scalable. Java was designed with security in mind, with features like bytecode verification, garbage collection, exception handling. It keeps your application safe and reliable. Rich standard library. You don't have to build everything from scratch. Java does come packed with powerful APIs for collections, input and output, networking, file handling, multi-threading, and much more. And these are something which you can use right out of the box. Scalability and performance. Whether it's a small tool or an enterprise level system, Java does scale effortlessly. The just-in-time compiler helps optimize the performance for faster execution. Vibrant ecosystem with tools like Maven and Gradle, frameworks like Spring and Hibernate. Java's ecosystem makes the development process much more easy and reliable and efficient. Plus, there is a huge community you can be part of, which is always there to help you out with pretty much any problem you might face during the development process. Backward compatibility. Java does respect older code. Application written years ago can still run on the latest versions, making it perfect for long-term projects. Portability. Java applications can be packaged into jar files and they can run on any platform that Java supports. That is where you can install the Java runtime environment. Powerful IDE support. With smart IDEs like IntelliJ IDEA, Eclipse, NetBeans, you get interesting features like auto code completion, debugger, error detection. This saves a lot of time and it boosts productivity while working on complex Java projects. At the very core of Java lies a powerful principle, that is object-oriented programming. Java uses object-oriented programming to model software just like the real world, that is creating objects that have data and behavior. This makes your application much more intuitive to design and easier to maintain and better organized. At the center of object-oriented programming is the concept of a class and object. Classes are like blueprints defining the structure, whereas objects are the real entities which you interact with. Let's say, for example, a car. Attributes of a car, they can consist in a class that would be the blueprint of it, whereas a car is an actual object which you would be creating out of that blueprint. Encapsulation is all about keeping your data safe. By using private fields and public methods like getters and setters, Java ensures your data is controlled and protected from unwanted interference. Inheritance allows you to reuse and extend your code. For example, both car and bike are actually vehicles. That is the superclass. The classes like car and bike, they can inherit from the superclass. You don't have to write common code for bike and car. You just place it in the superclass and it can be reused. So that's how it shares the behavior and it reduces the overall code duplication. Polymorphism means many forms. It lets different objects respond differently to the same method through overloading and overriding, making your code much more flexible and adaptable. The concept of overloading and overriding is something which we'll look later on in the inheritance chapter. Abstraction helps you focus on what matters. It hides unnecessary complexity and shows only the essential features using abstract classes and interfaces to simplify large systems. Abstraction is something we'll see in its dedicated chapter. Altogether, these object-oriented principles help you build modular, scalable, and reliable applications. Let's explore how Java powers the enterprise world applications around us. Java runs at the heart of global business operations, from customer service portals to cloud backends. Java is trusted by enterprises to build secure, scalable, and mission-critical applications and systems. In enterprise systems, Java powers everything from banking platforms and insurance systems to ERP solutions. These systems handle sensitive customer data and complex business workflows reliably and at scale. For web applications, Java shines with tools like Spring Boot, Hibernate, and Tomcat. Think of e-commerce sites, online banking sites, customer service portals. These serve millions of customers every day, and Java is something that makes that possible. In the world of cloud computing and microservices, Java is cloud native ready. It integrates seamlessly with Docker, Kubernetes, supports CI/CD pipelines for continuous integration and deployment, and it has SDKs and libraries available to integrate well with most popular cloud platforms like AWS, Azure, GCS. When it comes to big data and analytics, Java is the engine behind technologies like Apache Hadoop and Spark. It processes massive amount of data for fraud detection, analytics dashboard, and personalized AI recommendations. When you're learning Java, you're just not learning to code. You're preparing yourself to build critical, high-impact systems that are used in industries across the globe. Now let's connect the dots between Java and your journey as a full-stack developer. This is where it shines. Full-stack development covers both the front end, that is what users see, and the backend where all of the logic resides. And Java, it specializes much more in the backend. Java handles core business logic, API development, database access, and security, all the things that make web application functional and reliable. Frameworks like Spring Boot, They make the process of development much more efficient and simple. Java backend connects smoothly with modern front-end frameworks like React, Angular, using the REST APIs or even the GraphQL language, which we will explore in detail in the Spring Boot section. And Java ecosystem gives you everything you need to work on these things, from powerful IDEs like IntelliJ, Eclipse, build tools like Maven and Gradle, and even integration with CI/CD pipelines for automated deployment process. When you're learning Java, you're just not writing your simple code, you're actually building robust, scalable and production-ready backend systems that are part of full stack development. So let's walk through a simple practical roadmap which will help you in progressing in this journey one step at a time. Start with the fundamentals by learning the basics, that is the concept of object-oriented programming, getting comfortable with Java syntax, the control flow, the exception handling. Practice by writing small programs like calculator, number guessing application, or even as simple as an address book. Practice clean coding, build good habits early in your journey. Use clear variable names, write helpful comments, which gives you an idea about what your code does. Keep your code modular with small reusable methods. Readable code is maintainable code. Will build real projects. Apply what you learn by building some real world applications. Try creating a simple to-do list manager, a simple banking system, or a simple REST API using Spring Boot, which we'll see later on. Projects is what turn theory into a skill. Learn libraries and frameworks. Spend some time exploring Java libraries like Java Collection Framework, libraries for handling files, the input and output, multi-threading, networking. Then gradually move on to powerful tools like Spring Boot, Hibernate to build industry level applications. Follow best practices and join communities. Learn how to structure your code using design patterns, improve performance and stay updated with Java world. Engage with forums, explore GitHub projects and become part of the Java developer community so that you get to know a lot of different and interesting things what other developers are doing. And as a final tip, just start building. There's no perfect time to begin. Just start coding. The more you build, the more confident and skilled you'll get. That brings us to the end of this introductory chapter. Start small, stay consistent and keep growing. Every small project, every small code you write is one step you take closer to becoming a proficient Java developer. In next chapter, we are going to explore interesting concept of the Java ecosystem, the JVM, the JRE and the JDK. And that's about this chapter. I'm Venkatesh Mudalia. Till I see you again in the next one. Cheers.